Now some algebraic expressions are a little bit require a little bit more creativity to handle. So here's a perfect example, number 3. Notice again we can't plug in 4. The first thing you want to try to do is just plug in the value for x. So if you plug in the value for x, you get 0 on the top and 0 on the bottom. So that's a problem, because 0 divided by 0 is not a numerical value. So what can we do? Well, we could try to factor. Now it might seem strange for me to tell you that we can factor this, because that top looks like it's done factoring. It's just x minus 4. It would be different if it was x squared minus 4. So I want to pretend for a minute this was x squared minus 4. So if that top there was x squared minus 4, we know that that factors into x plus 2 and x minus 2. And even if it was if it was an x to the 4th minus 4, depending on your factoring skills, you may notice that that's also x squared minus 2 times x, oops, that's not a 4, x squared minus 2 times x squared plus 2. And, you know, if I had x to the 10th minus 4, you can factor that into x to the 5th minus 2 times x to the 5th plus 2. In other words, you can factor all these the same way, and the pattern you may notice is that whatever the degree is here, it gets halved in each of the factors. Right? 5 is half of 10, 2 is half of 4. So with that in mind, we actually could factor the top if we were willing to go into fractions less than 1. So think about it. I can factor that top into x to the 1/2 minus 2, x to the 1/2 plus 2 divided by, and now square root of x is another way of writing x to the 1/2 minus 2. So this is a clever, creative way to factor and actually get that bottom to cancel. So now those divide, and I'm just left with the limit as x goes to 4 of x to the 1/2 plus 2. And now I can substitute in my 4. This is 4 to the 1/2 plus 2. But 4 to the 1/2, remember, you want to be good with going back and forth between notation. The x to the 1/2 is the same as the square root of x. So 4 to the 1/2 just means the square root of 4, which is 2. So there's our answer. So there's a clever way of getting around that. It turns out we could factor that, even though it didn't seem like we could at the beginning. And finally, let's look at this problem here. So the reason that this process is called algebraic techniques is because sometimes we just have to use algebra to manipulate the expression so that we're allowed to substitute in that 0. So can we substitute 0 in right away? Well, we can in the top. You get 1/3 minus 1/3, but then you'd be dividing by 0, and again that's a problem. So we can't do it as is. So we may have to do some algebra to this 1/3 plus x minus 1/3 over x. So let's kind of isolate that so we don't have to keep writing the word limit over and over. Let's change how that looks. It looks like, I'm going to shrink this up a little bit so I have more room. It looks like 1/3 plus x minus 1/3 over x. I can probably change that by or change the top and kind of hope that x in the bottom will cancel with something in the top. Now how do I add these two fractions or subtract them? I need to get a common denominator. So the common denominator, if we just focus on the top, it looks like we need a 3 plus x and a 3. And so it looks like In this expression here, I would need to multiply the top and the bottom by a 3 to get that 3 times 3 plus x at the bottom. And this needs an x plus 3, or 3 plus x. I'll write 3 plus x so that it's not confusing. And then the top needs it too. So now that expression becomes, in the top, 3 minus 3 plus x divided by our common denominator. Don't forget that all of that is over this x. And now watch what happens. What we want to have happen is going to happen, fortunately. So this can reduce to 3 minus 3 minus x divided by 3 times 3 plus x divided by x. And now that becomes negative x on the top divided by 3 times 3 plus x divided by x. And whether you understand that these cancel right away, or you view this as x over 1 and then multiply times the reciprocal, you'll see that those x's cancel, and what you're left with is a negative 1 over 3 times 3 plus x. So in other words, just by doing a little bit of simplification, we got this x down here to cancel. And in my original problem, don't forget, I'm really trying to do the limit as x goes to 0 of this expression. So the answer is the limit as x goes to 0 of negative 1 over 3 times 3 plus x. And now we're in a good position to just do straight substitution. So put in the 0 for the x, and you get negative 1 over 3 times 3 plus 0 is 3, which is negative 1/9.